I'm Mike Stanzik, and this is Digital Electronics Classroom. In this video, we're going to be looking at how we convert from a decimal number to a binary number. And if there's anything in this video that seems that we haven't discussed until this point, that you're having trouble understanding, take a look at some of the earlier videos that might have the information that you're looking for. So we are looking to convert a decimal to a binary. In an earlier video went from binary to decimal, which I think is the easier way of doing the easier procedure. But this one's not bad either, and I think you're gonna get it pretty quickly. All right, so there's two methods that we're gonna look at, and the first one is called successive division. And in the successive division method, we're going to continuously divide by 2. Until we get 0. And what I mean until we get 0, that means the quotient is 0. So, I'm not going to explain exactly why this works, but I just wanted to explain the method for you at this point. And so I'm going to step you through that method, and maybe in a later video we'll talk about exactly why this works, but this does work. So let's just get started with an example. And so in this example, we're going to take the number 42 in decimal, and we're going to convert it into our binary. And so we're going to do successive division. So I'm going to take 42 divided by 2. And I'm going to get a quotient, Q, and I'm going to get a remainder, R. And so in this case, the quotient is 21, and the remainder is 0. And then I will take that new quotient, 21, and make it the dividend and divide it by 2. And so now I have 10, and now we have a remainder of 1. And then I'll take that new quotient, and divide it by 2, and we'll get 5, remainder 0. And then I'll take that 5, divide it by 2, and now we get 2, remainder 1. And I'll take that 2, divide it by 2, and now we get 1, remainder 0. And then I'll take that 1, divided by 2, and I'll get 0. So that's what we're looking for with a remainder of 1. Okay, so that's the procedure. And what we're going to look at is the binary number is going to be contained here in the remainder. So this is going to give us the binary number. Okay, and we're going to read it from the bottom up. So this will be the start, and we're going to read it upwards to the end up here. So this creates our new binary number, which is starting from the bottom there, 1, 0, 1, 0, 1, 0 in binary. And that's the method. So to understand, or to do a check, it's good to do a check afterwards. And so we already have the method of going from binary into decimal, so we can use that here and write this out. We have the powers here, 0, 1, 2, 3, 4, and 5. So we're going to have 1 times 2 to the 5 plus 1 times 2 to the 3 plus 1 times 2 to the 1. And so here we have 2 plus, this is 8, and this is 32. And so we can see that is indeed 42 base 10. And that is it. Thanks for watching. Hope you enjoy. And now for our second method of figuring out what the binary number is given a decimal number. And so in this case, we are looking at the example where we have 42 base 10. And what we're going to use is a table. Use a table of powers of 2. And so I have n and 2 to the n, like so. And so I got 0, 1, 2, 3, 4, 5, 6, And it's easy to build this table because powers of 2 will be just doubling the number. So 2 to the 0 is just 1, and then 2, 4, 8, 16, 32, and 64. And so now the procedure is we ask the question, what do we need to make 42? And we're going to start at the bottom and move upwards like this. So do I need 64 to make 32? I do not. And so we're not going to need 64. Do I need 32 to make 32? To make 42? Yes, I do. And so then I have 42 minus 32, and that is 10. So I have 10 left. Do I need 16 to make up that 10? Nope. Do I need 8 to make up the 10? Yes, I do. So I have 10 minus 8, and that's 2 left. Do I need 4 to make up that 2? No, I don't. Do I need 2 to make up that 2? Yes, I do. And so then I have 2 minus 2. That means there's 0 left, and so then we do not need the 1. And so we have this check x pattern, and so that corresponds to 1, 0, 1, 0, 1, 0. And again, we're going to read this going from the bottom towards the top. And so, oops, I think lost it here for a second. So yeah, so we have the end over here and the start over here. So again, we get our number as 1, 0, 1, 0, 1, 0 in binary. And there we have it. Thanks for watching.